Good afternoon, class. So at this point, you guys had some homework, and the homework was exercise. Sorry? 2. On page 96. Okay, so exercise 2 on page 196, you had to do numbers. Sorry? 1 and 2. Any problems with number 1? Okay. Number 4 you said, no? Okay, 1.4. Anything else other than 1.4 in number 1? Any other problems? In number 1? Okay. Any issues with number 2? 2.4. Not 4. 4. And 4 and 5. Okay, so hang on. I like this work, so it doesn't matter. No, we can't. I just said that for the video. Okay, so I got 4, 5, 6, 7. Is that what you're saying? Okay, that's fine. Anything for you, no? You just don't go outside. You guys did last time. You forgot? Wasn't it this group that was toying and what? No. Right, 2, 6 and 7, eh? Sorry? 7, yes. 7. Right, here we go. So the question was in the okay, what page is this? This is exercise 2, page 196. No? Oh yeah, that is this class again. No, I don't talk. Find the equation of the tangent and the normal. Don't worry about the normal. The normal is basically a line that is perpendicular to the tangent. Okay. It was going to be asked in the syllabus. Well, I don't know, I'm also not sure. But for some reason or other, this textbook added in. It was in the old syllabus. So I'm only going to work out the tangent, okay? Because the normal is not asked, so it's useless spending time on that. Okay, so if we look at this here, we have a circle. Okay. The center of the circle is half and 3/2. And the point of contact is at 1 and 4. So the tangent that they want you to work out is a line going through like it. And this is the equation we're going to work at that point of contact. Not so. So what we do is, this is your radius and this is your tangent. The radius stands 90 degrees to your tangent. Okay? So as you can see, we can't work out the equation of the radius, of the tangent straight away. We have to first work out the gradient of the radius, and we know the gradient of the radius times the gradient of the tangent is equal to -1. So let's work out the gradient of the radius. It's going to be y2 minus y1 over x2 minus x1. So it's going to be 4 minus 3/2 over 1 minus half. Let's put that in the calculator. It's going to be 4 minus 3/2 over 1 minus a half gives you 5. All okay with that? So the gradient of the radius times the gradient, this is small m, no? Gradient of lowercase m is equal to -1. So what's the gradient of the radius? 5. Times the gradient of the tangent is equal to -1. So the gradient of the tangent is equal to -1. Okay. So we can now conclude therefore y is equal to -1 over 5x plus c. So that's the gradient of this line going through here. Not so. So to calculate c, I can only substitute the point this line on this graph, which is 1 and. So we got x is 4, 1 and y is 4. Take that over, becomes 4 plus a fifth is 4 and 1/5. So therefore your equation is y is equal to -1 over 5x plus 4 and 1 over 5. Now you see we got fractions here. Not so. Now sometimes the textbook, what they do is they multiply to get rid of the fractions. Okay. So what's my LCM here? 5. So you will get, in other words, 5y is equal to -x plus 21. And then they give you an answer in that format. Okay. That they wanted in fractions. Which form does this textbook give it in? The fractions. So that's the answer they got there. So answer right? Okay. So who asked this question? Right, where you got wrong, Michael? -6. So here you got 1 over 6. You got 1 over 6 here. Yeah. Then you substituted 4 and 1. So you got 3 and 5 over 6, which is 18. You got 19 over 16.
I didn't substitute.
What did you then substitute? You can never substitute half and 3 over 2, ever. Because that is the point of contact here, which is 1 and 4. That's the point you said. So you made 2 mistakes in that sum, so you would have gotten nothing after that. Yeah. You see, we get positive marking as we go through. So you make 1 mistake, they deduct 1 mark. And then they work with your mistake. Provide your mistake makes sense to work. Not sense, but with your mistake, you had made no other mathematical error. You understand? So if you had gone and you substituted 1 and 4, then you would have gotten the answer I gave you. Then you would have gotten you would lost 1 out of 4, so you would have gotten 3 out of 4. But because you made your substitution was also a mistake, you'd probably gotten 1 out of 4 no marks. And that's our positive marking. Alright? But in a proof, if you make a mistake, so we mark from the top down in a proof, like when you must prove a theorem or something. Marking from the top down. If you make a mistake, at that point we don't mark after. You don't get positive marking on a proof. You must get a proof right. Okay. So we mark from top down. Right. In 2.4 we are told, find the equation of the tangents to the circle x minus 1 all squared plus y plus 4 all squared is equal to 17 at the origin. Find the equation or equations of the tangent or tangents to the circle. So let's draw. Let's see what they're talking about. Draw, no? So x is 1, y is negative 4. The square root of 16 is 4. So the square root of 17 is 4 comma something. So from the center to this point here is 4. Not so. So the root of 17 is a bit higher than that. So what's going to happen is it's going to go, they're talking about the center. Something like that. Okay. Find the equation or the equations of the tangent or tangents to the circle at the origin. So this is what they're talking about. This is the tangent they're talking about. Can you see that? Who asked this question? You understand?
Yes.
Did you get this part out? I'm sure you can do it from me. Must I still do it? Oh my word. That's your radius, that's your tangent. Right. And remember that the radius stands 90 degrees to the tangent. That's your origin, which is 0 and 0. So the gradient of the radius equals y2 minus y1 over x2 minus x1. Alright. So that's going to give you negative 4 minus 0 over 1 minus 0. Negative 4 over 1, which is negative. Doesn't make sense. Can you see the radius line to the left? Or it's decreasing. So it makes sense why it's negative. So we know the gradient of the radius times the gradient of the tangent is minus 1. What's the gradient of the radius? Negative 4. So negative 4 times. Gradient of the tangent is negative 1. Gradient of the tangent is going to be a quarter. So what can we do now? Y is equal to a quarter x plus c. But we know what c is. C is your y-intercept. What's the y-intercept of this line? 0. So that is going to be therefore y is equal to a quarter x. Okay. You understand? Okay. Any confusion here, people? Somebody forgot the lunch bag? The pencil bag. Oh, Layla. Who's Layla? Does anybody know a Layla? That answer right? Yes. Well, let me know when I'm wrong. No? Exercise 2, page 196, 2.5. Let's put this a bit lower. Find the equation or the equations of the tangent or tangents to the circle which is parallel to the x-axis. This is a nice question. Then again, all these questions are nice. No? Alright. So, you all agree that the center of the circle is at the origin. You should agree. Then we have a radius of what? Square root 7. Because this was r squared. So this point here would be what? Square root 7. The coordinate form will be 0 and root 7. What would this be? Root 7. Yes. This here? Negative root, no? The root 7. This one here? You see that? So they want to know what's the equation which is parallel to the x-axis. If it's parallel to the x-axis, we'll go through like that. Not so. So if it's parallel, there's a tangent. Can you see that? So what is the equation of this tangent? Y equals square root 7. Of course, the other one, it's 2 here. One going through like that. What will the equation of that line be? Y is equal to negative root 7. Right, makes sense? Look at the next question. That's all there. What else do you want to do?
What's the answer, sir?
Y is equal to root 7 and y is equal to negative root 7. Check what's right. I feel better, you know? Yes? E square root 7. Remember that the radius is from center to circumference, and the radius of this is root 7. That's why from there to there is root 7, root 7, root 7, root 7. Understand? Alright. Look at the next one, which is parallel to the y-axis. Okay? So again we draw. If things doesn't make sense to you people, you draw. Okay? So it's going to be negative 3 and 2. What's the radius of this line? Of the circle? 5. So if I drop 5 from here, it's going to take you to which point? Negative 3 and negative 3. Can you see that? So this was your radius. Okay? We'll go up by 5. But negative 3. We'll go up by 5. It will take you here. Not so? And that point would be what? Negative 3 and 7. If I go 5 in this direction, what would that point be? 5 in this direction. It will affect your x. Negative 8 and 2. Go 5 from here in that direction. Why 5? Radius. So what would this point here be? Negative 3 plus 5 is 2 and 2. You will understand. So that is your y and your x. The question was, it's parallel to your y-axis. This line is going through here. Parallel to your y-axis. Okay. So this tangent here, this second, is a second for all the way here. Not so. But when does it become a tangent? It's going through that one point only. Okay, that point that drew wrong. You will try, no? You guys get the idea? As I. So this point had to be a bit higher. But you guys get the idea, no? So what would the equation of that line be? What would the equation of that line be? X is equal to 2. Again, if you take this line here, it was a tangent at this point. The tangent at that point there as well. Okay, it will all be in the same line because my circle is not drawn to scale. Okay, and what will the equation of this circle, of this tangent be on this side? X is equal to negative 8. Make sense? Alright. Take that what you need. Okay, let's go on with our lives. 2.7. Determine the equation or the equations of the tangent to tangents which is parallel to the line. Y is equal to negative x plus 3. So what I do is again draw. Is the origin. Okay? So they didn't tell us that this is a tangent. The tangent will be parallel to this line. Okay? So the y-intercept of this piece here is going to be 2 root 2. The y-intercept of this here is going to be 3. So this line might go cutting through it at 2 points. Might be. Or even might not be. Okay? But what they're telling us is that the tangent is parallel to this line. So how can that help us? If lines are parallel, gradients are equal. So you see this is a tangent now. No? You see it will be there. You see at this point here. And it will be here. Which is at that point. Can you see that? So the tangent is going to touch at 2 points. You're going to have 2 tangents coming up. You guys understand? Okay. Again, it is parallel to this line. The tangent is parallel. So even if it didn't cut and we draw the black line there, okay, it still will be parallel. It will still be there and there only. Can you see that? So what's a tangent? The tangent is a straight line that's cutting it at 1 point only. Not so? Right. So where do we start? We know that it will be in the form of y equals mx plus c. That's the equation of the tangent. So currently you've got y is equal to negative x plus c. So how do I really calculate c? What do I need? I just need that point of contact. If I have the point of contact, I've done the job. Not so? We have the equation of the circle and we have the equation of another line. So we say, okay, let's put this here. To get these points out, okay, what I'm going to do is, I'm going to draw a line perpendicular to the known line. If it's perpendicular, what do we know? It's 90 degrees, yes? But we know the gradient of that line. So this gradient of this green line is equal to 1. I say, hang on. We know it's going to the center. How do we know it's going to the center? Because of the center of the circle is at the origin. Do you see that? So we know the center of the circle, so we know the C value as well. So the equation of the line in green is y is equal to 1x plus c, and c is 0. So that line in green is y is equal to x. So how is that going to help us find those points here? How is that going to help us find those points? Is the line in green not cutting the circle? So those points are what? The points of intersection of the line in green and the circle. How do we calculate the points of intersection? So is the two graphs equal to each other? Here we're not. We're going to substitute simultaneous equations. X is equal to y is equal to x into the equation of the circle. So what do we have then? X squared plus y squared, which is x squared, is equal to 8. X squared plus x squared is 2x squared is equal to 8. Divided by 2. X squared is equal to 4. Square root thereof plus minus 2. So there your x is negative 2. And there your x is 2. How do I calculate my y value? By substituting that into any one of the previous equations. Definitely going to go with the easier one. So that would be y is equal to plus minus 2 as well. So if y is 2, if x is 2, y is 2. If x is minus 2, y is minus 2. So there's negative 2 and 2. So they are my points of contact. Okay? So what do I do now? So let's go with the first one. Now we're going to substitute 2 and 2. Okay? Into the tangent equation here. So we have y is equal to minus x. No. X is 2, y is 2. So 2 is equal to minus 2 plus c. C then works to be 4. Therefore y is equal to minus x plus 4. That's the first one. The second equation, of course, is y is equal to minus x plus c. Again, we're going to substitute negative 2 and negative 2. So that's a x and a y. So negative 2 is equal to negative 2 plus c. That is positive 2. Take it over, becomes negative 2, which is negative 4. Y is equal to negative x minus 4, and this is second equation then. Okay. Okay. So yesterday we spoke about the first two examples, no? We only did two examples yesterday. Now we did one. Worked example 1 has two sums in it, two different examples of the same, under the same heading there, worked example 1. So now we must do worked example 2, not so. Determine whether the line, okay. Worked example 2 is on page? Sorry? What page is this one? 194. Okay, so here we are told, determine whether the line y equals x minus 5 is a tangent to the circle. So what does a tangent mean? It cut the circle one point only. So if I work out the points of intersection and the solution is one solution, then it's a tangent. Okay? If it's two solutions, then that means to say that it will be a secant or a secant. Not so? It cut 2 points. If it cuts 1 point, it will be a 1 point will be a tangent. And if I got no solution, then how many points is it going to cut? So you're not going to cut it. So again, if my solution is 2 points, it will be a secant, or a secant. If it's 1 point, it could be will be a tangent. And if it has no x values, it will be none of it. Okay? You guys understand? So what happens is, we're going to do simultaneous equations. If this equation 1 and equation 2, we're going to substitute equation 2 into equation 1. Simultaneous equation. So what do we get now? Let's do the substitution. If I see a y, I replace it with y minus 5. So carry on, I will get x squared minus 4x plus x minus 5 squared equals, to simplify this out for me quickly. Alright, so what do we get? X squared minus 4x plus x squared minus 10x plus 25 is equal to 5. So that's going to give us x squared, 2x squared, minus 14x, bring 5 over it becomes positive, 20 equals 0. Is that correct? X works out to be, 5 or 2. You can use a quadratic formula or a calculator, or you can factorize. You first divide by 2, of course, and then solve it. Did you all get that? So is this a tangent? No. What will this be? A secant. Okay. Therefore not a tangent. It will then be a secant. Okay. Otherwise, if that was a perfect square trinomial, then it would have come out to be x is equal to 2 only, or 5 only. Okay? Does it make sense? Let's look at worked example 3. This is on the same page. I suppose I have said the example 1, 2. Okay, in worked example 3 we are asked, show that circle x plus 3 squared plus y minus 4 squared equals 4 touches the circle x squared plus y squared equals 9. Okay. So what we do is, there's some theory here you need to know. We have two circles. Okay, let's make one bigger than the other. Alright. Let's say this radius of the circle R1 is equal to 2 and R2 is equal to 5. That's the case. Okay. So, if you have a case where these circles touch each other like that, okay? Let's say this is A. The center of the circle we call that A, and the center of the circle we call it B. Okay? If R1, what would this distance of AB be? 7. Not so. So they're touching each other at one point only. Okay? So if R1 plus R2, the length of R1 and R2, the length of the radius of the first circle plus the length of the radius, if that is equal to AB, the length of AB, what can we say? We can say that the circles touch each other once. Okay. So if the radius 1 plus the radius 2 is equal to the distance between the radii, the distance between the centers, sorry. If the radius 1 plus the radius 2 is equal to the distance between the two circles, center, then that circles touch each other at one point only. Can you see that, people? Does it make sense? Alright. Now let's take this away. If you now have if this is now the case, what do you see now? You got the radius 1, the length of radius 1, plus length of radius 2, and the distance AB now. Which distance is larger? The sum of the two radii? You got 2 plus 5, which is 7. Is radius 1 plus radius 2 smaller than or larger than the distance between the two centers of the circle? Small. Why? Because we are taking that into account, and this distance between the two circles into account. That is why the distance between the centers is definitely larger than the radius 1 and the radius 2. Can you see that, people? So what note can we make here? If the distance between the centers is larger than the sum of the two radii, what can we say? Circles does not touch each other. Not so? So make a note here. If radius 1 plus radius 2 is less than the distance between the centers, then the circles does not touch each other. if that was the case? What if that's the case? You got your radius 1 plus radius 2, the length of radius 2, and you got the distance between the two centers. That thing on top means you say the distance, okay? Which one is larger? Remember? From A to B. From A to the circumference is 2. From B to the that circumference is 2. You see as a 5, sorry. You see as an overlap here. Okay? So what can we say? That radius 1 plus radius 2 has to be more than AB. Not so? If that is the case, what do we say? Therefore, the circle cuts each other twice. Therefore, the circle cuts each other twice. Or 2 times, no? Twice right or 2 times? Both is right. No? Alright. So if the radius 1 plus radius 2 is equal to the distance between the centers of the circle, they are touching each other once. If the centers of the circle is larger, the distance for the centers of the circle is larger than the radius 1 and radius 2, the circles does not touch. If the distance of the two centers of the circle is smaller than the sum of the radii, then they cut each other twice. Okay. So let's go back to what they have said. Okay, the question. So show that the circle, so we have 2 circles. Let's make the circle A. So what will the center of the circle be? Write this down. And that is B. I want you guys to write the centers of the circles and the radii. There's radius 1, radii 2, and the length of the radii of each circle. Do that quickly. So what is the center of circle A? Negative 3 and 4. What's the length of the center of circle B? 0 and 0. Okay. The radius 1? 2. Radius 2? 3. So what is R1 plus R2 equal to? 2 plus 3, which is 5. Not so. So if the distance between A and B is 5, the circle touches each other at 1 point A. Not so? Right. So, how are we going to calculate the distance between the two centers of the circle? Distance formula. So use the distance formula for AB quickly. So that will simply be the square root of negative 3 plus 0 squared, which is 9. 4 plus 0 squared is 16, which is the square root of 25, which is 5. Also, so what can we say about the circles? Touch each other once. So we say, since, we state the obvious, the radius 1 plus the radius 2 is equal to the distance of AB. Therefore, the two circles touch each other once. If AB, if this calculation here had to come more than 5, then what would have been your conclusion? Then I would have said R1 plus R2 is less than AB. Therefore, the circles don't touch each other. If AB was less than 5, what would you have said then? R1 plus R2 is more than the length of AB. Therefore, the circles touch each other twice. Okay? Makes sense? Just a matter of how you're ending off that argument. Okay? Or the question. Okay, any confusion thus far? Any confusion? No? Not yet? Okay. It's only until you do the work yourself. No? Work example 4 on page 194. This will be the last time we're doing today. Your homework is of course going to be number 3, 4, 5. 3, 4, 5 homework. Yes, this is one of the days where you must go clean the class, no? Okay, there we go. So 3, 4, 5 for tomorrow. And then I will conclude with example 4 and 5. Okay. People enjoy the rest of your day. Good afternoon, class.